Okay, so in this chapter we learn about the selection. In this chapter we learn about the selection structure, relational comparison operator, and logic, or logic, and not logic. Make the selection which ranges, and it can use a combination of the and or operator and case structure here. So the selection structure is a Boolean expression. It can be only or true or false. Right? You know that Boolean is always yes or no, or true or false, 1 or 0. Right? And every computer decision, it can be true or false, yes or no, or 1 or 0 here. And it's used in every selection structure. So when you think about selection structure, you always have the condition. And yes, you do something. Right? No. Okay, so in the selection structure, you can have the dual alternative. Dual alternative, that means you can break it down into 2 branches. Right? So it checks the condition. It checks the condition here. If yes, if the condition, it always have the condition. Yes, you do something. No, we do other thing. Right? That no, we do other thing for this one here. And can I move to the next one? From here, can I do it? From here? No. This one? No. Yes. Okay. And then is a single alternative here. Right? You have the single alternative. That means you have the condition and yet you do something. No, you do nothing. All right. Now here is the example of that is the example of the selection structure here. So in this program, right? In this program, in this program, so in this program, you got the input from user. The input here it is what is housekeeping? You see what is housekeeping here? Housekeeping here, right? The same. You got the name, right? You got the name of the employee, and this one you do again for many employee here, right? So for each of employee here, you need to get the hour work, right? Enter the hour work. So how many hours you work for a week, right? And get it the hour here. Now you check the condition. If here, that means the selection, right? If the number hour here greater than work week is it? That means if you work more than 40 hours in a week, you got the overtime pay, right? You got the overtime pay here. See, if that greater than, right, you figure out work week here, time rate, that means you have a 40 time normal rate. And you also have the overtime here. Overtime, that means you time with the overtime rate on that. Think about if you enter the number 45, right? Number 45. So basically, you have the 40 hours of normal rate, right? 40 hours of normal rate. Right here, the 15 here. And you have the 5 hours of overtime, right? You have the 5 hours of overtime here. 5 hours, right? Times rate 15 and time overtime rate is 1.5 here. Right? So we see. If greater than overtime, you got the overtime rate, right? If not, the pay it at normal, right? Pay it at normal. So this one is a very simple program. It do the same. You have the structure here. You have the housekeeping, right? You get the hour. You figure out the pay, and again, you see at the end also, you need to move on to the next employee here. Right? You move on to the next employee. That's why again you need to enter employee name here. And remember this one. This one is only for the first employee, and this one for the next employee, so on and so on and so on. Right? So for this one here, for this program, you can see I write on both of the router and the Python here, and you see. For this one here, the housekeeping. What is housekeeping? Housekeeping. The main purpose of the housekeeping, I got the employee name of the first employee, right? You got the name of first employee. Now, after that, I come back to the main program. I check name equal to quit or not. That means name equal to ZZZ here or not. If no, right? I go with the detail loop. So what is the detail loop? infinity loop here. I get the hour. That is a selection here. That is selection here, right? That is a selection. That is a selection in the raptor here. I check it here. I check it for the selection here. If hour greater than 40, work week here 40, right? I figured out that is a pay which includes the overtime, but not you just do it normal, right? So and print out the what the pay here and do the same, right? So see for this program here, when I run it, when I run this program starting from the right, see, I do everything with this one here, right? So now what's the name? Right? So this one here, I exit, I come back to the main body, I move to the loop, check the condition. Yeah, you see, name here David is not equal to quit, right? It's not equal to quit. You know that quit here is ZZZ, right? That's why you go into your loop. Can you see it? You go with the detail loop here. In the detail loop, you do everything. You got the number of hours, right? You got the number of hours here. So think about I enter the number 45. You know that 45 greater than work week, that means 40 here, right? So we go with the years. Go with the years. Right? I got the overtime. Okay now. Right? Now I see. If I want to move on to next employee, right? I have to add another one here, right? Look, think about this one here. Okay, do it. How about this guy? This guy only 20. So we see 20 is just got the normal pay only. No overtime. That's why I know here. Now I want to exit it. Put this is it. Check. Correct. And absorb overtime. Correct. So we see that is the output of my program. This the David guy here, he worked the 45 hours. That's why he got the overtime, but this one here is no overtime. That's why. Now see, I do the same. You can do it the same with the Python as well. You do the same with the Python. So we see that in the structure of the Python, it's exactly the same. This class is not required to do with the Python separately. You just need to do with the virtual machine. But anyway, if you want to learn more about the Python, you should know how I structure this one here, right? So for this one here, you see, for this one here, you see the same, right? You have the same here. This one here, that is prime input or housekeeping. That's the name for the first employee. Check the condition here. If not, right, is that check get the hour here. If hour greater than work week, got the overtime, right? If not, do it print out again. Got the new name of the next employee. You do the same. Do the same. Structure always the same. Structure always the same. The only difference here is that you have the selection here. You break it down into two branches. If you greater than 40 week, 40 hour, you got the overtime. If not, do it normally. Make sense? Okay. What is it? Can you see it? Yeah. Okay. So that's the selection structure here. You have if, then, and else decision. If then clause holds the action or the action execute when the test condition is true. And else not true. That's all. Else not true here. And remember that to do the selection, you only have the condition to check. And in order to do the condition, they call it the relational comparison operator. So what is the relational operation operator? You have the 6 types of relational operation operator. They are greater than, the first one, less than, equal, equal. Normally in the real programming language, when you use equal, you have to use a double equal sign, not only one single, right? You have greater than, less than, equal, greater than or equal, right? Greater than or equal, less than or equal, or not equal, right? So you have the 6 types of relational operator overhead. Greater than, less than, equal, greater than or equal, less than or equal, or not equal. Yeah. So for any selection, you always have to use one of the 6 relational operator here, right? Okay. Think about this one here. You have to compare 20 equal to 20 or not. You give you out the true, right? But 30 is not equal to 40. You give you out the 4. So output here is only true or false. That's all. Only true or false, right? Okay, so we see you have the equal here, right? You have greater than, you have less than, you have a greater than or equal, less than or equal, or not equal here. In the pseudocode, right? In the pseudocode, you can see not equal is that this one here. Not greater than, not less than, right? Sorry, not equal here. Not the same. But in the Python, you can see, you can check by this one. Not equal, right? Okay, any decision can be made with only 3 types of combination: greater, equal, less than, or greater than. Or you can use the combination of this one, right? Okay. Now think about this one here. They are do exactly the same. They are do exactly the same, right? You have seen the first thing you have if customer equal or greater than 65, you have discount 0.5. Sorry, 0.1, right? If not, you have no discount. This one also. Now we see on this one here, basically. You can see about this one here, you have to draw the line here. Sorry. Here, or this one, you have to draw the line here, right? You have to draw the line. Starting from 0, you come all over to 65 and include the 65 and come over greater than 65, right? So see for this one here, if customer greater than or equal 65, that means everything on this side, right? Everything on this side, include the 65, you have the 0.5. Sorry, you have the 0.1 discount. If not here, else, that means not, right? If not, that means everything less than 65, you have no discount here. The same as this one. I check again, right? If customer less than 65 is this one here, right? You have discount 0. If not, you have discount 0.1. The two of them work exactly the same, right? Work exactly the same here. Also see what this one also, right? You have the if the customer code is not equal to the number 1, if not equal to number 1, you have the discount 0.35. If equal to number 1, you have the discount by 0.5 here. I do the same with this one. You just switch it here. Now, sometimes you can use a compound condition. Compound condition, that means you have more than condition. You have a more than condition here. That means you ask multiple questions before the outcome is determined here. For the AND decision, it requires both to test equivalent to the true. And if you know about the true table, right? I mentioned about the true table later. But for now, you just know that for the AND logic here, the AND logic, right? You have the AND logic. AND logic in the computer, in the AND logic, in computer, you can think about you have the 2 input here, and you have the 1 output. That's AND logic. And remember, in the computer, it's always 0 and 1. And that's why you can think about 0, it is a 4. And 1 here, it is 2. You can think about this one here. So for AND logic, the output is only 1 when both of the input is 1. Or the output is 2 only when both the output is 2. You can think about this one here. For the AND logic, you have 1 and 1, you have the output is 1. But you have 0 and 1, you have 0. And you have the 1 and 0, you have 0, and you have 0 and 0, you have 0. So you see, the output here is only 1 when both of the input true. The output is true when both of the input true here, right? And normally for the AND decision, it requires netted decision here. They are put inside each other, right? They will put inside each other here. Now you can think about this one here. You can think about the understanding about the logic here. Oh, I think I modified it, but I'm not put it here. Now it's this one. Okay. Now, the understanding about the AND logic for this one here, right? The AND logic for this one. This program here, you got the premium rate only when you make more than 100 score and the minute of the call minute is greater than 500 here. And remember and here, right? So see, if you look on this one here, the structure, everything the same. You have the housekeeping, you have detail loop, and you have end job here. Now, if you look on this one here, if you look on this one, if you look on in the pseudocode here, you can see this if here, right? This if here, put it totally inside this one, right? You can see it. That is a negative decision. It's negative. That means you put one condition totally entire inside another one. That is negative decision. You can see this one here, right? You can see this one here. That is the condition. You check if the call minute greater than 500 or not, right? Again, you have to put it inside totally other one. If the call minute greater than 100 or not. That is negative decision here, right? So in the Raptor also, it's very simple. If you work with the Raptor also, right? In the Raptor here, you can check. Sorry. In the Raptor also, you can put it here, totally inside it, right? This one here, totally inside the other one. That is negative decision. Why we must do it again? Okay, so for the netting decision, in the netting decision, is a selection can compose. It doesn't matter. Yeah, is a selection compose. So performance time can be improved by asking question in the proper order. That is very important here, right? And in the AND decision, it normally first answer question is less likely to be true. And so if you have the two conditions, in order to do with the netted decision here, the AND decision here, you should ask the question that's less likely to be true here. Now, let me show you how we do it here, or this one here. Now, let's see. Think about if you want to go to the army, right? If you want to go to the army, you need the two conditions to be true. The first one, you have to be greater than or equal 18. Age, you have to older or greater than 18, right? And the weight must be greater than or equal to the 140 here. So we have the two conditions. You have two conditions here, right? So we can put it in the netted decision here. The first, or this one here. In the first, on the left one, you check the weight first, right? You check the condition of the weight first. And now, if true, again, you have to check if age greater than or equal to 18 or not. You see, the output here, you see, the output is up here. First condition. The second condition here. The output here is that you are eligible to join the army. Only both of them are true. You see, yes here, right? And yes here. Only both of them are true. Do the same with this one. Now we just reverse order. You check X here, greater than 18 or not, correct. That this one correct. Check greater than or equal to 140 or not, correct. You do. You can join the army. In any other case, you are not able to join that. This is a compound decision here. You use a 2n, and in the Raptor you net to each other here. Now, think about this one. I have many guys here. I have one guy, other guy. I have many guys here. I have many guys here. I look at them, right? I look at them. They seem to be quite old, right? Quite mature, but it's not really reaching to the weight of the 140. So I guess that they have the high probability of less than 140. Right? So for that one, I raise this question first. Right? So we see if they are not 140, for sure, they are not able to go to the job. I do not need to check the age anymore. Right? So for that reason here, when you work with the AND logic, normally for the first condition, you have to check if the condition has the less probability of being true. You see, I look at this one here. They have no way greater than 140. I have no way greater than 140. So I just check the question. Are you greater than 140 or not? If not, drop them. So for this one also, or this one here, I see that they are very big. They are very big, but they are the way they behave is not immature. It's not immature, right? So I guess that they might be not greater than 18. Right? So see, the first question here, I reverse it. Are you greater than or equal to 18 or not? No, I'm too young. Drop it here. Right? So for this one here, when you work the AND logic, you can do with this one and this one. The output is the same, but the way the computer processing is not the same. The way computer processing. So the first condition, if you have the less probability of being true, it really reduce the time of processing here. Right? You do not need to check the other condition anymore. I see. You do not need to check the other condition anymore. Make sense? Okay. Now, this one that works is the same here. It works the two program. Right? The output is the same, but the way the computer processing is not the same. Think about this one. Right? So think about this one. What happened? What do you think? What happened if I have the enter the edge of the 40 and the weight of the 120? What do you think? What I got for the output here? What I got for output? If this one edge here and the weight here. What do you think? What I got for the output?
You're ineligible.
What do you think? Eligible? No.
You can't join there.
Yeah, actually you have nothing in the output here. For this one, you have nothing in the output, right? That means you can understand that you are not eligible here. Right? Think about this one here. H40, correct. Correct here. Check again, weight here, not correct. It's not correct. That's why I go with this one. And you see, you have nothing in the output. Right? So for this one here, it's always true. You're only eligible to go to OMI when the age greater than or equal 18 and the weight greater than or equal to 1 volt. Right? So that you have to remember about the AND logic. The AND logic only true when both of the conditions true. Otherwise, in any other case, it always false. Make sense? Okay. Now think about this one. Sometimes I have so many questions. Okay, now we talk about the truth table, right? Which I asking about the truth table already. The truth table also. Where is it? Okay, now sometimes I can combine them together. Instead of putting the next decision, I can combine. Sorry, inputs of break it down into two separate and I can combine them together. Now think about this program here. I think about this program, right? Think about this program. I can combine them together by using AND logic here. I put the AND here and weight here, right? Weight here greater than or equal to 1. So this one, works the same. I can combine them in together. I see they combine them together in one line here, right? So you see, I can check it again. What happened? Right? What happened if I run it for the 40 here, and this one only 120? Nothing. Nothing here, right? You have nothing here. But this one here, you see, you can combine them together. But remember here. From the diagram, it looks not the same. But from the computer point of view, work exactly the same as the last one. So basically for this one here, again, the computer, you have to check if h greater than or equal to 18 or not. The first step, again, check weight greater than or 40 or not. And when both of them end, you are eligible to join. So yeah, for this one, you can combine them together, but from the computer point of view, it works the same. In the order. The first step, check h greater than or 18 or not. We move to the second step, check weight here greater than or equal to 40 or not. It works the same. So basically for this one here, you see for this one. For this one, from the computer point of view, we work the same. Even that in the diagram is not the same here. That from the computer point of view, you see, you check the ATS first, right? The first condition. Now we check the weight greater than or equal to 40 or not. Right? From the computer point of view, work exactly the same. Okay, so remember that in the case if you work a negative decision, remember one thing here. The second decision must be entirely within the first decision. That means you have to negative totally inside the first one, right? And in the more programming language, it's a okay. Now see what happened with this one. What happened with this one here? This one is this program I gave you on the last class here, right? So this one here, I ask user to enter the positive integer number. So to verify that it is a positive integer number, I have to check it is in the number format or not. Right? If the floor number equals the number or not, that means it is the whole number here. You got my point, right? You got the logic here, right? And the third one here, I have to check if number greater than 0 or not. Right? It's greater than 0 or not. So why I make mistake with this one? Sorry. I think there's something wrong with my slide. Okay, now let me talk about this one first. Now, remember in the case of the negative decision, you have to remember that the second decision must be made entirely input the first one. Now, what happens if I modify this program here? What happens if I modify this program? No, not this program. Whatever. No, not this program. Okay, let me modify. And remember that in the router, right? When we want to do the selection, you just go to the selection and drag and drop it here. Okay, so you see, remember when you work with the AND logic, right? Or what about it? If you work with nested logic, you have to put the selection totally inside another selection. Right? You see, this one here totally inside another one here. Now, what happens if I modify program, right? If I modify program here. This one. What happened? What do you think of what happened with this program? Is correct or not? Why not correct?
Because the second is outside of the first.
Yes. So now think this one, actually this one is all logic, not AND logic. This one is all logic, not AND logic, right? So you see, what happened here? What happened? I put, what happened if for this program, right? What happened if I put the program, I put the 40 here, huh? 40 here, you see, check totally you are eligible. But if it's a weight here, it's only 100. So even that it have no here, right? But it always print out you are eligible. So see, this actually is all logic, not AND logic. So remember that in the case that of the AND logic here, you have to put it totally inside another one. Totally nested in another one, right? See, if you can run this program here, you can see what happened with this program. Right? So see, if I run it here, I put the 40, and even that I only have 100 power. Right? See, you are eligible to draw down. It's not correct. It's not correct. That's why you see. Remember that in the case of AND logic here, you have to put it totally inside another one. Make sense? Any question so far? Let me know. Hello? Now, I come back to this example. Here. Now, that is an example, right? And now see what happened here. When I got the input, I have to check if it is a number format or not. And it's a whole number or not by using the floor number equal to number or not, right? And check the number equal to greater than 0 or not. But remember here, when you use the compound logic, the order of the logic is very important. You have to know for sure which one you want to check first. Right? Now see what happened if I run this one here, right? When I run this one here and I run this program for this one here. Now think about I enter the number 70 here, right? It's correct, right? It's correct. You are enter the correct positive number, right? And if I enter the number positive here, negative here, what happens? Negative 75. You have to enter it again. That's the loop here because the condition is not correct. So what happened? I put the 75.9 here. Okay, it's asking you to enter again, right? Now, if I put the number, now think about this one. If I put the number 40 here, again, so not in this number, right? Okay, ask you, so I have to enter the correct one. Now, see, it worked perfectly, right? I test all of the conditions. I test about the positive, negative, floating number, and string number also, right? Now, remember, the order of the condition here is very important. Now, what happened here? I change the order here. What happened is this one, I check it, it's a whole number first, before I check for okay, now see, I change the order, right? I change the order. I check if the number is a whole number first before I check it in the number format. So what happened here? What happened if I run this one? I enter the number 40. I got the syntax error. I got the program crash because it's here. When you enter the 40, you cannot use with the floor function here. Floor function only work with the number format, right? But when you enter the 40 in the string here, it doesn't work with the floor function. Right? So we see even that when you use a compound logic, you have to understand and you have to know, you have to understand about the order of it. Which one you have to do first and move on the next one. Make sense? Okay. Yes, this one is not correct, right? Because this one is not correct. Now, we already learned about the AND logic. Right? We learned about the AND logic. We learned about the AND logic. AND logic, remember that the output of AND logic only true when both of the input true. But on the OR logic is the take action when one or the other of the two conditions true. So at least you have one true, it's only true. At least you have one true, it's only true here. So think about this one here. You can think about this one. You have the one here, that means true, right? And you have one true, you have the true, that is OR logic here. You have 1 and 0, and 1 or 0, you have 1. And 0 or 1, you have 1. And you have 0 or 0, you have 0. You see, the output is only 4 when both of the input is 4. But in any other case, it's always number 0, number 1 here. All right, so that is OR logic. The OR logic, that means at least you have one is true, it's only true. Right? It's only true here. So think about this one. Are you free for dinner Friday or Saturday? That means whatever. Friday work and Saturday also work. Right? That is all. That's all here. Okay, so for this one here, right? So for this one here, now I change the program here, right? You got the premium rate when the call greater than 100 or not and here or message greater than 500 here. All right, so we see for this one here, you check for this condition here. Of course, if you have a greater than 100 call, immediately you got the premium rate. All right, and if Check again, right? If the text sent here greater than 500 here, again, you got the premium rate. Right? So whatever condition true, you got the premium rate here. Right? That is the all condition here. That's the all condition here. So to understand about this one here, let me ask you the question. If you make the 50 call, if you make the 50 call and you send about the 600 message, so what do you think? Do you got the premium rate or not? You got the premium rate or not? Yes. What do you think? If you only make for the 50 call and you send out the 600 messages, you got the premium rate or not? Yes, right? The thing is this one here. 60 here, sorry, 600 here greater than 500. That's why you choose. Right? So you do not care about this one. One condition true, the output of the all condition is true. I think it's the same, right? You check here, the call made 50 here, right? Not right, so we have to know. But you check here, greater than 600. That's why you have premium rate for this one. Right? So that you have to remember about the difference between the and the or here. Now, think about this one. Now, let me mention you again in the AND logic. In the AND logic, right? In the AND logic, normally you ask the first question have the less probability of true first in the AND logic. But in the OR logic, to make it better performance, you ask the question that the first the first decision have the higher probability of being true. That's the difference between the OR and AND, right? Because see, if you look on this one here, I don't care. If you look on this one here, what is this? Where? This program. There's this one here, right? This program here, right? So see, I know for sure that he had the high probability of the. I know for sure that he had a high probability of more than 104, right? That's why I checked the first condition here. So if yes, for sure he got the premium. I do not have to care about the other one, right? And again, if I know that he have a probability of send more than 500 here, I have to raise the question first. So that's the difference between the OR and AND. And you raise the first question, you have the less probability of being true. But in the OR condition, you raise the question with the high probability of being true. Okay. So basically, in the after yourself, see, you do the same, right? You just work with the selection here, and you drag and drop it, you check it. In the Python yourself, you do the same with the Python. Right? The Python, you check the condition here, right? Check the condition. Okay, so we see in the case of OR, you ask the question have more likely to be true. They're not the same as the AND, right? In the AND, because I see whatever I did, if the condition, the first condition true, it's only true only. I do not have to check for the second condition. Right? That's why the order of the decision is very important in the program here. The order is very important, right? And even though the output is the same, but the order is very important. And if you want to optimize your coding, you have to understand about the order of the decision. Okay, so we see for this one also, the boards of the structure here is the same. It works the same, right? It works the same. Now check if it call greater than 100 here. Call greater than 100. Instantly you got the premium rate. You do not have to check for the message here, right? And if the message here greater than 500, instantly you got the premium rate. and you will not have to check for the code. And of course, the order is not the same. The order is not the same, right? And you know for sure that he had the high chance of making more than 100 code. You put it outside. You put it the first condition. And if you know that for sure, he had the more chance of sending more than 500 message. You put it on the first condition. Again, for the also you can use right. For the all here, for all the all here you can use the compound also, right? You can put this one also, right? You can change this program to put all here, right? Put it for here. Copy this one. You can combine it into the one line and it puts all. Put the same. And of course, you release this one. It works the same. Okay? Make sense? Now we check the condition. We check the order condition here. Whatever. If code greater than 100 or message greater than 500, you got the premium rate. If not, right? No. Okay, so you have avoiding the common error in the OR selection here. So basically here, the second question must be self-contained structure with the one entry and exit point. That means you will put it inside here, right? Now, we can A and B in English logically mean request for all and A or B. Now see what the difference here. Add 200 to the bill of anyone who makes more than 100 call and to anyone who is more than 500 minutes. That is when you talk, right? But actually, when you convert it into the program, this one is all. This one is all of the here. So whatever it is, if he greater than 100 call or if he send more than 500 minutes, you got the premium rate. But when we talk over here, add 20 to anyone who make more than 100 call and to anyone who is more than 500 minutes. So that you have to pay attention, right? You have to pay attention when what is the requirement of the program. Okay, and avoiding the common error in all selection. Make sure the Boolean expression are complete. Selection are structure. All the section when it is required. Make sure the expression is not here. What is this? Now this one is not correct, right? This one not correct because this one is not totally inside the other one. Remember that you have to put it inside the other one here. This one. Now, also that is very, very common mistake error in all selection here. So think about this one here. Think about you have the program. Right? This is the program that asks you to ask about the age here, virtual age, right? And you have everything from 0. You have 13 here, and you have the 64 and more than 64, right? So this program here. So whenever you less than 13, whenever you less than 13 or whenever you greater than 64, you got the discount. You have got the discount price at the 60. Now, so in this program, you see, you have if partial age less than minimum age here, that means less than 13, right? And partial age here greater than maximum age here. Then you have you have got the discount price. So what's wrong with this one? What's wrong with this program? What do you think? What's wrong with this program? If less than 13 and greater than 64, what's wrong with this program?
It will never be true.
Yeah, never ever happen. Because the thing here, you cannot at the same time less than 13 and greater than 64. never ever less than 13 and greater than 64, right? So basically, in order to correct it, you have to use all function here, not the n function, right? Make sense? Okay, that is one of the common mistake here, or this one. Now the other one also, the other one you can change it here, right? You can change it here. If I think this one here. Now again, I draw the line here. You have 0 here, you have the 13 here, and have 64 here, and you create the 64. Now for this one here, you use all here. If the partial h greater than minimum h or partial h less than the minimum h here, then you got the full price. What's wrong with this one? What's wrong with this one? What's wrong with this coding here? What's wrong with this one? Tell me what's wrong with this one.
It will always be true.
It's always be true to everyone, right? So see, if greater than minimum h, that means everything here, right? And now all, you mean the all less than maximum h, everyone here, right? See, so in the end, that means for everyone. Right? So again, you have to correct this one with n here, either less than 13 or greater than 64. Right? Okay, that is also is a common mistake when you work with the compound or logic game. Now you learn about the and, right? You learn about the or. Now not that the reverse that one, right? That means you have the 2, you revert it to the 4, and 4 you revert it to the 2, or 1 you revert it to the 0, and 0 you revert it to number 1 here. Now remember that term here, right? And now this one. Where? This. Okay, this one. Okay, if not h less than 18, you can register the word. So what do you understand about this one? What is your translation about this one? What is your translation about this one? If you look on the if not h less than 18, then output can register the word. So what is your translation from this coding? What do you think about this one? In what scenario you can vote?
If you're equal to or greater than.
Yeah, right. So think about this one here. This one here again, you have everything from 0, right? And you have 18 and greater than 18. Right? So if not less than 18, right? Not less than 18, that means not this one here. Right? Not this one. That means you can include the 18 and greater than 18. Right? So you can understand this one here. If you are greater than or equal 18, you are eligible. So basically, this one is the same, right? This one is the same. If h greater than or equal 18, huh? The same. Now, think about the incorrect code for this one here. If not employee department 1 or not employee department 0, then the output employee is not in the department 1 or what here. So what do you think? What's wrong with this coding? What's wrong with this one? What's wrong with this one? What's wrong with this one? Now tell me what's wrong with this one? What's wrong with this the first one? What do you think? Why wrong? Why wrong with the first one? What go wrong with the first one? Any idea? Why it go wrong with the first one? Now, to change that very simple, right? Change that very simple. Think about you have employee department. You enter the number 1 here. So what happened? Now see, employee department equal to number 1, right? That means this one here, true, right? This one is true here, right? And true, and if not of the true, that means the first one you have 4. You have the first one, you have the 4 here, right? So on this one here, you have a 4 for this one. Make sense? Now think about this one here. Employee department number 1 equal number 2 here, 4. But not of the 4, you have the 2 here, right? So see, this one is the 2. And if you use all them between them, 4 and 2, what do you have? You have 2. Right? So think even that, he enters the number 1. The employee is not in department 1 or 2. It's not correct. Right? So in order to correct it here, you have to put all of them, all. Right? All of them means all. You have to do all first before you do the not here. Make sense? Right? Okay. That is the problem here. Right? So that's why you have to pay attention in the not expression here. Again, you have to know the correct order using the parentheses and everything here. Again, anytime if you are not clear, let me know. Right? And even the online for the online student here, anytime you can interrupt me. Anytime if you have any question here. Honestly, I prefer you to raise the question as much as possible. Otherwise, very boring class. Now, working with the range, making selection with the range. I think, yeah, take a short break and come back in the 10 minutes. I know I had that. Okay, so now we move to the making selection with the ranges. So basically, so far we just do with the selection. We break it down 2 branches, right? Yes, do something, and now we do the other thing. In some case, you have to do with multiple selection. You have to think about here, compare variable to series of value between the limit. That is range check here, right? So normally you use a lowest or highest value in each range. You can use either lowest or highest, right? And adjust the question logic when using the highest versus the lowest here. And point includes yes, greater than or less than here. Now think about this one here. Now that is range here. That's the range here, right? So think about this one here. You have to write a program, right? You have to write a program to figure out what is the discount rate based on the item order. Right? So if the customer order the 10 or less than, you have no discount rate. Right? And if everything from the 11 to the 24, you have 10%. And everything from the 25 to the 50, you have 15. And greater than from the 51 or more, you have the 30%. That's the range, right? You have the range. You have break it down into many range, and you can see 0 here is the lowest range. You can use that, and of course you can the highest range. It can go to infinity, right? Now for this one here, right? So for this one, I don't know. I suppose that I have to do in the slide here, but for this one here. Now, in order to with the range here, you have to do 2 ways to do that. The first one you can work with a long way here. This is a long way. A long way. So with the long way, you check every single condition there, right? Check if the condition here less than or equal 10, right? You print out, you have no discount, right? And so on. Check the other condition here. So we see, I got the enter item here, right? I work with selection here, and I check if less than. You have the less than range number 1 here. I put the range number 1 at 10 here, right? I put the number 1 10 here, and range number 2 I put it is 15 here. And range number 3, I put it is 30 here, 20 here, right? So now we check here. You check if the item order less than or equal to 10, correct? I have the discount here. Discount here is discount number 1. And again, I check if in the range from the 11 to 12. If yes, I put the discount here. But you have huge problem with this one here. What do you think? What is a huge problem with this one here? Now see, if I open the pseudo code here, I open the pseudo code for this one. Why? Yes, this one. So we see, I set the range here, right? And why I don't have the? I think I make mistake here. We have the we must have the 15 on server or sorry, so the 15 on server. Have the brackets here. 15. What's the range? You have 20. Right, sorry. You have the discount number 0. That means you have no discount, right? 10%, 15%, and 20% here. Now I got the item. I got the item. I think I have not checked this one. I not save it yet. Check here. Check here. Check here. Oasis, sorry. One, two, three, four. Okay. That is the long way here, right? So you see, every time I got it, right? Every time I got the item order here, I check it into range. What is the range here? Range here, right? It's range here. Range less than 10, right? Less than 10. Less than 10, I have the discount number 1, that means I have 0, right? I have the 0 here, and so on here, right? And so on. Now think about this one. I check it here. Right? I run the program, and I have the item order. I have number 5 here. Because the 0 discount, correct, right? What happens if I enter the number 16 here? 16. You have 0.15. Right? Output is correct. Output is correct, right? But what do you think about this program? What do you think about this program? What is the drawback of this program? What do you think? What do you think about this program?
It could be condensed a bit.
Sorry?
It could be made smaller, condensed,
Huh?
like it's long, like it's,
But why long?
because it's checking for each and every.
Yeah, right. The thing is that here, whenever you enter the number, you always have to check for all of the conditions here. Right? You think about this one here. You can think about this one here. That's correct. You think about this one here. When he enters the number 5, right? Check the condition. Correct, right? And print out the discount here, 0, right? But again, you have to check again for this one. You have to check again for this one. And you have to check for again for this one. It's really slow down process, right? Whenever you enter the item number, you always have to check for all of the possibility here, right? So in order to do that, in order to overcome this drawback, if you use a netted decision here, right? It's a netted decision, you put it inside another one. So you see, this one here is a netted decision here. All right, let me open this one. Now this one here, right? So here I put it netted together. I put it netted together for this one. Yeah, I put it netted together, right? So see what happened here. What happened if I enter the number? What happened if I enter the number 5, right? What happened if I enter the number 5? So see, it check the correction here, right? It check the correction. Yes, correct. Print now. You have 0 and exit of the selection process. You do not have to check for other one here. You do not have to check the other one here. Right? So basically for the range, you will with the netted decision. You put it one decision inside another one here to make it more efficient, right? Now, that is something about the netted decision, but remember something about this one here. Some of the common mistake when you work in netted decision that you put it too much work on the netted decision here. Now think about this one here. I see that some of very common mistake when you work with netted decision that you work with a dead end. Now what is the dead end? Now think about this one here. I have another selection for this one. So you check again, check again. Yes. Now this program work. Output it work exactly the same with the last one. It works the same, but you have a problem with this one here. You have a problem with the program here. The code is the dead end. The code is the dead end. That means you have the part but don't do anything. You have the part but don't do anything. So think about this one here, right? You have the range for this one. You have 0, you have the 10, you have the 15, and you have the 20 here. Right? So how it works? Check that. Check it less than or equal to 10. Work on this one. Right? Now move to the second one. It checks less than or equal to 15 here. It work with this one here. Right? The third one here, check from the 15 to 20. Work with this one here. Now see, you only have one option greater than 20 here, right? So you do not have to check this one again. You do not have to check this one again here. You really slow down process here. Right? If the computer, you think about, if you enter the number 25, the computer has to check, and again have to check it. But you know that for sure that whenever you have everything with this one, and this one, you only have one left option here. And for sure it's greater than 20, right? So do not do on this end. This end they call it the dead end. Really slow down process, right? So that is the first common mistake when you work with netted decision. So instead of that, you know for sure, you just drag and drop here. You do not need to check this one again. You do not need to check this one again for sure. If not less than 10, if not less than 20, sorry, if not less than 15, if not less than 30, for sure, it's greater than 20. No here, that means greater than 30. You do not have to check it again. That is the first common mistake here. The second one here. The second one, some of you, when you work with this one, again, you put it on this one here, right? And push it back here. And item. Order greater than again, correct this one. And item order greater than two here, right? So now, see, the output is the same. The output is the same. It works the same. But again, it's slow down process here. It's slow down process here. Actually, for this one here, right? Actually, for this program here, you do not need to check this one anymore. You do not need to check this one anymore. How? You think about it. How here? Okay, you have the 10, sorry, you have 0 here, you have the 10, you have 15, and you have 20 here. All right, so now see what happened here. If you enter the number 5, it already is on this one, right? Never ever on the other one here. If you enter the number 12 here, what happened? If you enter the number 12, it check the condition here, right? It's not correct, so you know for sure. You do not have to check this one anymore. Right? You check already here on this step here. You do not have to check if greater than range 1 here. Actually, see, it was the same here. Right? You do not have to check it again. So for this one here, again, you tell the computer that you have to do the compound logic here. Check again for the less than range 2 and check again if greater than range 1. Right? Know for sure that it already checked here. You do not have to check for this one. So basically, you do not need to implicit this one. You do not include this one. Make sense? Yeah, you see, for any program, you will always have to try to optimize the code. Now you see, it's a complicated program. If you have a long way or have a long instruction, it's very slow down process. Right? So if you can optimize, you do not have to do this. Right? That is some common. Actually, it's not the major mistake, but whenever you think about you want to optimize the code, you have to think about this one. So see on this one here, right? You just netted together. You just put it netted together here. Right? You put it netted together, and in the Python also, you just put here if else, and so on. Right? Else. Now see, avoid a dead or unreachable path. That's what I mentioned. Right? That's what I mentioned here. You do not have to check it again for this one. You do not have to check again for this one. If for sure, if not less than 10, it's not less than 15, it's not less than 20. Of course, it have a greater than or equal 20 here, right? So you do not have to check it again for this one. Really slow down process. So instead of that, just copy and paste it here. That is a one common mistake for this one. The second one is the second one here. You have to check it double here. You have to double check it for this one. For this one here, right? You do not have to check it greater than range 1 here or not, because this step already checked it here. And again, you do not have to check this one because it already checked it here. Make sense? Okay. So in the homework, I believe that you will have the netted decision here, and I expect you to understand about the net parts and about avoiding the same range region multiple times. And this one here, do it again. It's multiple times. Okay. So when you combine the multiple and or operator in the expression, when the multiple condition must be true, right? Use the multiple and here. Remember that if you want to make sure everything to be true, right? You have to use the and, right? You have to use the and here. So if you look at this program, what is the purpose of this program? What do you think? What is the purpose of this program? Can you translate it? Can you translate this program? What is the purpose of this program?
If all the scores are greater than or to the minimums.
Okay. Yeah. So think about this one here. You can think about if you set the minimum score to 60 here, right? The student only pass it when all of the score here, all of the 3 score greater than 60. Only when all of them, because you add logic here. Right? So see, it only passes when all of them. So even that he has the 100 for the first one, you have the 100 for the second one, and you only have the 0 for the third one. You fail. You fail for this one. You fail for this one. Even that average here, he have a greater than 60. So that is you have to remember about that. If you want everything, when your multiple position must be all true, use the multiple and here. How about this one? How about this one here? How we translate this one? How we translate this coding here? So what happened if you have the 100 and you have the 0 and the 0 and minimum score here 60? What happened?
It'd still be true.
Yeah, it passes it. Because all here, You have the all function. You have all here, right? So see, you have 100, right? Greater than 60. This is true. Remember, for the all compound, whenever you have at least one true, the output is always true, right? So that's why we pass it even that we have 0 and 0 for the second one. Okay, so that you have understand the difference between the AND and the OR logic here. And when AND and OR operator are combined in the same statement, remember the AND has the higher probability. And have the higher probability here, right? So if so basically you can think about this one here. You can think about if H less than equal to 20 or H greater than 20 and rating Z here. So basically you see you have AND, that means you have to break it down into two portions. You have to do ANDing first. You have to do with the ANDing first. So see the first thing, this one you have to think about this one here. Oh, right? Okay, and of course, when you're mixing the AND and OR orbital, makes the logic more complicated. Right? The more complex, the more complicated, and you can avoid mixing AND and OR digits. Okay, break it down. The thing that you want to combine them, just put them together. And if you want to make it simple, just break it down into the netted. Right? It's a netting statement here. Okay, think about this one here. Right? Now this one here, the same, right? He got the discount here. I think about this one here. So he will got the discount when he less than 13, less than 13 or greater than 65, and rating equals G here. So see, now this one here. You can do whatever it is, right? So see, you can do the rating G first, right? Because this one actually you have the two compound here, right? You have to compound here, and remember you have to do the AND logic first, right? You have to do AND logic first. That's why you have to check with the rating here, greater than, right? And after that, this is the selection because it's all here. That's all here, right? That's all here. Right. Again. So. If you think it's complicated, just break it down into multiple netted decision here. Okay, so in some of the other programming language, you have the case structure here. You have the case structure, right? In the case, fusion decision there. Okay, this is case structure here. The case structure, that means whenever you enter the year, the programmer check it. It's 1, 2, or 3, or 4. Sorry, or by default, it print out what the 2 should be. That's the case. In some of the real programming language, work as case, right? But in interrupter, you cannot do this. So you have to understand. So normally interrupter, you have to work with the netted decision. So I think that's all for the. That's all for the slide for today. Let's on the next class we'll learn about the set theory, truth table, logic gate, and also I mentioned a little bit about the Python because you also have the homework with the Python. You also have the homework with the Python for this one. So any question so far? Let me know. Any question? Hello? So on Thursday again, I do it. I will go with the remaining about the set theory, truth table, and logic gate, and also instruct you how to work with the selection condition in the Python. You work with a single alternative, you work with dual alternative, and you work with the net decision with the Python here, right? And again, at normal, and I will have you do with the sum of the spread first pseudocode, right? Normally the first one and the second one. But I do hope that you understand about the logic now, right? And if you need to clarify it, send me the email. I can send him the recording. So again, I strongly recommend you that you have understanding about the logic, about the main logic here. In the main logic, you see in the chapter 2, chapter 2 about the main logic. Right? In the chapter 2, the main logic. Right? So see, if you understand about the logic, when you translate from the pseudocode to the logic here, you can see what is happening, what's going wrong with the pseudocode. Okay, that is the same. Everyone is the same. Because when you understand about the structure, about the main logic, everyone will be the same. And you know that they want it a standard. They want everyone to follow the same standard. That's why they have a structure here. Okay, so I think let me check the attendance here. Zachary Baker, are you here? Zachary Barrow, are you here? Cameron, are you here? Cameron, are you here?
I'm here.
Yeah, I'm here. Richmond, are you here? Emiliano, are you here?
I'm here.
Okay. Riley. Kaden, are you here?
Yeah, I'm here.
Jasmine, are you here?
Yes.
Luke, are you here? Luke, are you here? Diego, are you here?
Here.
Oh, sorry. Nick, are you here? Jack, are you here? Jose, are you here? Jose, are you here? Martin, are you here? Martin, are you here? Shannon, are you here? Nathan, are you here? Aiden, are you here?
I'm here.
Okay. So again, if any one of you need the recording for the pseudocode correction, send me the email, remind me, and send it to me. Okay. Okay. So see you guys on Thursday. Bye bye.